Bismillahirrahmanirrahim. Let's talk about environmental biodegradation of explosives. Now, why this type of biodegradation is of concern? Because in so many areas, especially the areas which were used to be battlefields in the past, or the areas where there has been industries for the manufacture of explosives or military bases as well, those areas and the surrounding areas are prone to be contaminated by the explosives. And these explosives, apart from being explosives, these can also be toxic to life. And when these contaminate soil and water, they can bring about many toxic effects on human life. Now, obviously, there has been a lot of disposal of explosives in the past in so many different types of environments. And if those environments are inhabited by human beings or other life forms, obviously those are at risk. So therefore, it is basically a long-term challenge. Still, we come to hear so many different news every day that from different sites, different types of explosives, buried explosives were discovered. So obviously, those things are there, and they need to be located, removed, and biodegraded as well. So if those are not removed, those must be biodegraded. So there must be some microbial enzymatic processes which can act on these compounds and can degrade them. The most important interest in degrading them or removing them from different sites is especially in case of decommissioning of some military bases for some other purposes. So if a military base has to be decommissioned and has to be used for some other purpose, obviously if it has been contaminated or there has been some exposure of explosive in the soil or water, that has to be remediated. There can be so many different approaches by which these compounds can be degraded. Obviously, one of them is incineration, but as we know, it is an expensive process. Moreover, it cannot be employed for the contaminated wastewaters. So obviously, we have to look for some other techniques, and biodegradation is one of the promising technique in case of degradation of and remediation of explosives as well. Now, there is a typical characteristics of explosives, that is the presence of nitro groups. So a nitro group is present in almost all kinds of explosives, and if that can be targeted, some specific types of reactions can take place to degrade these explosive compounds. TNT is one of the most known explosive compound, and the transformation of TNT can result in the reduction of nitro group to form an amino group. The reactions can be either microbially enzymatically catalyzed, or it can be brought about by abiotically as well under proper reducing environments. So we can see here that a compound can not only be degraded directly by microbial processes, it can also be degraded indirectly if certain abiotic factors are there. So those abiotic factors can be present there naturally, or those can be brought about by indirectly by different microbial processes as well, which we will discuss in our upcoming lessons. Now, commonly found in TNT contaminated soils are the intermediates of the degradation of TNT. हमने पहले भी डिस्कस किया कि जब भी किसी कंपाउंड की बायो ट्रांसमिशन होती है, ज़रूरी नहीं वो कम्प्लीटली मिनरलाइज हो जाए. कभी ये होता है कि वो कंपाउंड जो है किसी और कंपाउंड में चेंज हो जाता है, वो कंपाउंड ज़्यादा टॉक्सिक भी हो सकता है और लेस टॉक्सिक भी हो सकता है. एंड समटाइम्स इट आल्सो हैपन्स कि कंपाउंड की बायो ट्रांसमिशन स्टार्ट होती है, लेकिन वो ख़ास होता जाके रुक जाती है. तो इंटरमीडिएट कंपाउंड जो है वो फिर प्रिवेल करते हैं एनवायरनमेंट में. ऑलमोस्ट सेम गोज फॉर TNT कंटामिनेटेड सॉइल्स, एंड द इंटरमीडिएट्स कैन बी फाउंड देयर. उसमें से जो दो ज़्यादा अहम है वो हैं 4A-DNT एंड 2A-DNT. इसके अलावा कुछ और भी पाए जाते हैं. उनमें जो ज़्यादा इंपॉर्टेंट है वो 2,4-DNT एंड 2,6-DNT हैं. सो दीज इंटरमीडिएट्स आर मोस्टली फाउंड इन द एरियाज इन द कंटामिनेटेड सॉइल्स which have been exposed with TNT. Now, these transformation products are and can be subjected to further transformation and biodegradation processes. They can also interact with each other as well to make new combinations of compounds. And these can also interact with the soil particles and organic matter present in the soil, and they can soak there as well. So depending on the types of reactions that they undergo, उसके मुताबिक उसकी रिकास्टेंट कम होगी या बढ़ जाएगी. These can also form stable complexes as well due to such interactions with each other and with the soil particles and the organic matter. Therefore, these can result in much larger molecules which are much more insoluble, and therefore if they are insoluble, they are much more unavailable to the microbial systems. So obviously they will become more recalcitrant. So therefore, even if TNT is disappearing from a site, we cannot say that it has been remediated or the site is safe now, because इस केस में हमने देखा कि TNT की इंटरमीडिएट प्रोडक्ट्स जो हैं वो इंक्रीज कर रही हैं और वो भी आपस में इंटरेक्ट करके नई किस्म के कंपाउंड्स को कॉन्जिनस बना सकते हैं, बना रही हैं. So complete mineralization नहीं हो रही. So even a toxic compound has been disappeared from a certain site, we cannot say that the site is safe for human activities. We have to make sure that when the compound has disappeared, whether it has disappeared into and has been converted into less toxic and non-toxic forms or not, or whether it has been completely mineralized or not, or in worst cases whether it has been converted to some other toxic forms. So बेशक environment में कोई toxic compound disappear हो गया, लेकिन ज़रूरी नहीं कि वो mineralize हो गया. It may be possible कि वो disappear होकर किसी और toxic form में, किसी ज़्यादा toxic form में convert हो जाए. So obviously environment is still not safe. Perhaps it is much more toxic now. Now toluene, benzene and phenols containing one or two nitro groups, those can be subjected to biodegradation much more readily as compared to other compounds जिनका हमने जिक्र किया अभी. Initial monooxygenation or dioxygenation can be there. हम पहले भी यही जिक्र करते आ रहे हैं कि it starts with the oxidation process. So in case of toluene, benzene, those can be degraded completely to minerals. Complete mineralization हो सकती है. There are so many other explosives as well, and these can be much hard to degrade as well. As compared to TNT, RDX can be more readily mineralized. So different types of जो explosives हैं, उनकी जो degradation है वो different है. कुछ ज़्यादा जल्दी degrade होते हैं, कुछ degrade नहीं होते हैं या time लेते हैं. कुछ explosives ऐसे हैं जो कि completely degrade होकर mineralize हो जाते हैं. कुछ जो है वो intermediates तक ही transform होते हैं. So RDX can be mineralized, लेकिन इसके rates जो हैं mineralization के obviously slow हैं. Another explosive compound HMX, इसकी transformation भी होती है primarily under anaerobic conditions, and इसकी transformation is much slower than RDX. अगर हम plants की बात करें तो yes, many plants are also known to bring about transformation of different types of explosives. So there is potential for phytoremediation as well, which is the remediation using plants. This was about the biodegradation of different types of explosives. I will see you in next lessons.